welcome to another video on phase lines. Today we're going to be doing y squared minus 1 minus y quantity squared, right? So gotta FOIL this out so we can find the zero. Well, we'll find the zeros of it and then we'll FOIL it out to see what we can do to find the derivative. Okay, so now these are all kind of like pretty much the same story when you're doing them. The only thing that gets a little like messy is the algebra sometimes. I know the first example I did, we had like 3 plus or minus root 33 over 4, which is really just as hard as these get. There's not much else to them. So we know where the zeros are here just by looking at it. We know that we have y equals 0 is where y prime is going to equal 0. Remember dy over dt is equal to y prime, where y prime equals 0. That's going to give us our equilibrium points for the graph. So this time we don't have a plus or minus 1, we just have y equals 0 and y equals 1, right? So now we can make note of that. Our increasing and decreasing values are going to be 0, 1, so let's start plugging in. So anything less than we'll start with more than 1, right? 1 minus 3 squared is going to be positive, right? Anything squared that's a negative is going to be positive. So positive between 0 and 1, well, that's still going to be a positive. 1 minus 1/2, it's going to give you a positive. Anything less than let's say negative 1, y minus negative 1, it's going to be positive still. So this thing is increasing throughout. Okay, so mark this as, my writing's pretty small, but just know that that's for increasing and decreasing. So now let's go ahead and FOIL this out and find the inflection points, which I have a feeling is going to be a little bit different this time than last time. So I'm going to go ahead and write dy dt is y prime. So y prime equals, we'll leave this y squared out here and then we'll go ahead and FOIL this out. So we'll have negative y plus 1, it's just simple algebra at this point. So y squared minus y, so minus 2y plus 1, right? So y squared minus 2y plus 1. Now let's go ahead and distribute this y squared term. So y prime equals y to the 4th minus 2y cubed plus y squared. And now let's take the derivative to find what the inflection points are going to be. So to do that, we just have to use implicit differentiation, remember, because we have to use the chain rule. So always remember that you got to tag on that y prime. So 4y to the 3rd y prime minus 6y squared y prime plus 2y y prime. Right? Okay, so I'm going to erase this and we'll keep going here. So now let's factor out a 2, a y, and a y prime. So 2y and y prime. So y double prime equals 2y y prime, and then we have a 2 here, a y squared, so 2y squared, and then we have a 3 on a y, so minus 3y, and then plus 1. So let's make sure that that's correct. So 4y cubed y prime, negative 6 y squared y prime, and then 2y y prime, right? Okay, so now we know what y prime is equal to. Y prime is just this, so let's plug this back in. So we have, actually, so what I'm going to do, yeah, we'll do this. Y double prime equals 2y and then y prime, which is y squared 1 minus y quantity squared. And then we have this, 2y squared minus 3y plus 1. So let's go ahead and find the roots of this. If you have a calculator that can solve it for you, I recommend that because we're not in algebra. We can afford to be kind of lazy. We know what the quadratic equation does. 3 and 1. So we get the roots of 1 and 1 and 1/2. So let's go ahead and see if this is right. So we'll say 2y minus 1 and then y minus 1. So this will give us 2y squared. Actually, yeah, is that right? Y squared, yeah. 2y squared minus 3y plus 1, right? Okay, so this is what this turns into. So I'm going to go ahead and rewrite this as this right here. So 2y minus 1, y minus 1. Okay. So now what we can do is we can use this equation, now that we found y double prime, we can use this equation to find the inflection points. And we'll do that by finding the zeros of this function first and testing all the points in between it. So I'm actually do it up here. I'm going to erase this. And let's test all of these inflection points. So we have y equals 0. I'm going to rewrite this a little bit prettier. 2y cubed, I just pulled out that y squared because it's all multiplied. 1 minus y quantity squared. 2y minus 1, y minus 1. So now that we have that, we can start testing points. We have y equals 0 for this, right? We have y equals 1 for this 0. We have y equals, well, 2y minus 1, where does that equal 0? 2y equals 1, y equals 1 over 2, right? And then y equals 1 again. So we have a double, yeah, we have like a double root here. So we have 1 twice is what I meant. Okay. So now let's start testing points. So we have 0, we have 1 over 2, I don't like writing fractions like that. We have 1 over 2, we have y equals 1, we have, so y equals 1 twice, so that was a way too big number line for what I'm trying to do. Okay, so let's rewrite this. 0, 1/2, 0, 1, right? Okay. So now let's start plugging stuff in. So we'll just plug in -1. This is going to be negative. -1 is going to be 1 minus -1, so that's 1 plus 1, so that's 2. 2 squared positive. So -1, so that's -2 minus 1. This is going to be negative. -1 minus 1, -2 is negative. So positive right here, these become positive, positive, negative. We're going to have this be a negative, concave down, and I'll go ahead and write this out to the side again. Remember that a local max is when it's going to be negative, concave down, yeah, positive. When you get positive over here, you're going to have a local min. It's going to be concave up, concave up, concave down. Okay, let's keep going. So a point between 0 and 1/2, let's just do 0.1. Okay, so 0.1, this is going to be positive. 1 minus 0.1, still positive. 2 times 0.1 minus 1 is going to be, I think that's going to be negative, right? 2 times, can't do mental math right now. 0.1, yeah, minus 1 is going to be negative. And then 0.1 minus 1, that's still going to be negative. So now we have 2 positives, 2 negatives. These become a positive. And we're going to get an overall positive. So concave up. So now a point between 1/2 and 1, just do 0.9. So 0.9 is going to be positive, 1 minus 0.9, this is going to be positive. 2 times 0.9 minus 1, 2 times 0.9 minus 1, yeah, that's going to be positive. And then 0.9 minus 1 is going to be a negative. So now we have positive, 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 and then the negative. So this is going to be negative and concave down on that interval. And 1 to infinity, so let's plug in 2. Positive, this becomes negative. 2 times 2 minus 1, positive. 2 minus 1, this is going to be positive. So this is going to stay negative. Right? So it doesn't oscillate this time. It doesn't go negative, positive, negative, positive. It goes negative, positive, negative, negative. It's going to concave down on that interval. So I'm going to copy this up here and then set up the graph. Okay, I have set up the graph and I'm ready to tell where my intervals are increasing and decreasing for the first derivative of the function. Remember the function was dy over dt equals y squared 1 minus y quantity squared. So now it's increasing on every interval here. So what we're going to do is we're going to note that by putting the little carets in there to tell us that it's always increasing. So now we'll start from negative infinity to 0. We know that it's increasing, and we know that it's concave down. So this is what it is going to look like. And notice the inflection point never changed, right? It was always just, you know what an inflection point is. This would be an inflection point, right? The concavity switches. At no point in this did that do that. So sure to make little notes of that and be sure to make sure that it looks right whenever you're doing it. So now increasing between, oh I'm sorry, I forgot to draw my inflection point, which was negative 1/2. Look at that real quick. Just put it right there. Okay. So this is y equals 1/2. Alright, so now we'll do from 0 to 1/2, right? Increasing throughout. From 0 to 1/2, where it is concave up, it is still increasing. So concave up and increasing is going to look like this up to that point. And then notice the concavity is probably going to flip, right? It could not, but most likely it does. So from 1/2 to 1, we have concave down, and you'll see the concavity does flip here. Alright, and then now from 1 to infinity, it is concave down and it is increasing. So let's see. Increasing. It's kind of a brain twister sometimes. You gotta do decreasing. Oh, I see what we did. Oh no, it's still negative. I made a slight mistake here. This is actually, I forgot about this squared right here. So this is actually going to be, if we plug in 2, right? Positive 2, 1 minus 2 is negative 1, but it becomes positive because it's squared. 2 is positive, and 2 is positive. So this is actually going to be concave up, right? And so the reason I caught that, how I caught that, was because whenever I was trying to draw my phase line, I thought it was concave down and it was increasing. So if I were to do that, it would have to look like this. And that's wrong, right? Because it runs into this equilibrium point. So I was like, there's something that's got to be wrong. I just don't know what it is. So that's when I knew how to go back and check my work and make sure there was not an error anywhere, but I knew there was because it can't happen like this. So that is something that you'll have to like look for in a test. If something's not just adding up, you'll have to like go back and work on it. So we know that it's concave up now after 1, and it is going to be increasing still. So so it's just going to look like this, and works perfectly with it. The concavity doesn't shift, and it is concave up throughout. So now let's go ahead and determine if they are stable, unstable, where the stability is that these points are. So let's see. So this is going to be semi-stable, right? It goes towards it and one's away from it. So let's see, semi-stable. Y equals 0. Remember, we're not worried about this. This is just an inflection point. This isn't an equilibrium point. So this isn't any sort of stability you have to account for in an inflection point that's not an equilibrium point. So y equals 0, this is also semi-stable because one's coming towards it, one's away from it. Alright. And those are some examples of phase lines. So I'll be back with some more material. Thank you.